This video is about the tangent function. This is AP Pre-Calculus topic 3.8. If you appreciate this content, please give it a like. The function g is given by g of x is equal to 1 minus 5 times the tangent of 1/3 x. What is the period of g? The period of a tangent function is pi divided by the b value. So in this case, the period will be pi divided by the b value of 1/3. When you divide by a fraction, you multiply by the reciprocal. So the period will be 3 times pi. And that's it. Number 2. The function m is given by m of x is equal to -3 times the tangent of 4 pi x. What is the period of m? Well, again, we know the period to be pi divided by the b value for a tangent function. In this case, the b value is 4 pi, so this will be pi divided by 4 pi. The pi's cancel each other out, so we end up with the period is equal to 1/4. Number 3. The function j is given by j of x is equal to 8 minus 7 times the tangent of x over 4. Which of the following gives the vertical asymptotes of j? Well, first of all, vertical translations and vertical dilations will not affect the position of vertical asymptotes. So we can ignore the 8 and the minus 7. I'm going to write this part in a thought bubble because this is not something you need to write down. But you should be thinking the tangent of x over 4 is equal to the sine of x over 4 divided by the cosine of x over 4. A vertical asymptote will occur where the tangent of x over 4 is undefined. That's going to be where the denominator, cosine of x over 4, is equal to 0. Therefore, and this is the first part you need to write down, we need to solve the equation cosine of x over 4 is equal to 0. Next, we solve for x over 4 by asking ourselves the cosine of what is equal to 0. On the unit circle, cosine is the x value, and x values are equal to 0 here and here. So the first solution is at pi over 2. That's what's up here at the top. We are not making a list, so I'm not going to put a comma and put 3 pi over 2, which is the next solution. I'm noticing that we need to make an expression representing the infinitely many solutions to this equation. Well, we can get from one solution to the next solution by adding pi radians. So adding pi will take us to the 3 pi over 2. If we add another pi radians, it will take us back to this position, and we will have another solution. So we will get another solution and another solution every time we add pi radians. So we can get the infinitely many solutions by adding multiples of pi. In other words, by adding pi k, where k is any integer. We still need to get x by itself, so let's multiply both sides of the equation by 4. If we do that, on the left side, these 4's cancel each other out, and we just have x. 4 pi over 2 simplifies down to 2 pi, and then we have the plus 4 pi k. Let's look for this expression among the answer choices. Let's see, 2 pi plus 4 pi k. The answer is C. Number 4, let f of x equal 2 plus tangent x. On which of the following intervals is the graph of f concave down? For now, let's ignore the 2 in the front, and let's graph a couple periods of the parent function y equals tangent x. We have memorized that the period of tangent is pi. So I'm going to come out 4 quarter periods and put a pi right here. This is negative pi over here. Half of pi is pi over 2. And here we have negative pi over 2. Half of pi over 2 is pi over 4. This is negative pi over 4. 3 of these will give me this. So this third mark is 3 pi over 4. So this mark right here is negative 3 pi over 4. The tangent function, the parent function, has no phase shift. That means our first point is going to start right at 0. And our phase shift starts right on the midline. There's going to be an asymptote halfway through the period. I just want you to memorize that. The parent function for tangent is always increasing. So at this first quarter period, it's going to be up 1 unit. And here we are approaching this asymptote. So it's going to look like this. The graph must continue to be increasing as we get back to the midline. So the rest of this period is going to look like this. So this is one period of the tangent function. I'm just going to sort of duplicate this on the left-hand side. The left period of the tangent function will begin and end on the midline, and it will be increasing the entire time. So I'm increasing through this point, which is at 1 unit, while approaching the asymptote. And then on the other side of the asymptote, I'm still increasing. I'm going to hit this point at -1, and it connects up like this. So, whoops, here are 2 periods of the tangent function. Adding the 2, if I were to put +2 on the end, which would be the same as having this 2 on the front, is just a vertical translation up 2. Moving this graph up 2 units would not change on which intervals it is concave up or concave down. So I can really just ignore the +2 because a vertical translation does not affect the intervals of concavity. So I can answer the question based on the graph that is in front of us. Look at option A. Is the graph concave up? Sorry, we're looking for a concave down. Is the graph concave down between -pi and -pi over 2? That's this first little piece. This is clearly concave up, so the answer is not A. What about from 0 to pi over 2? That's this red piece right here. From 0 to pi over 2, again, that is concave up. The answer is not B. What about pi over 2 to pi? That's from here to here. Well, this branch is concave down. So the answer is going to be C. But let's follow through and look at D. The interval from pi to 3 pi over 2. Well, that's sort of off the curve, but we're starting at pi, so you can kind of imagine that if we continued this graph any further, this next portion of the graph would be concave up just like this. So from pi to 3 pi over 2 would again be concave up. Number 5. The function k is given by k of x is equal to 1 plus 3 times the tangent of 2x. Which of the following statements about k is true? Well, first I see that they are mentioning the period. So we can narrow it down by finding the period of this function. We know that the period is going to equal pi divided by the b value for a tangent function. The b value is 2, so the period is pi over 2. That corresponds to options A and B, so C and D are out. Next, we need to come up with an expression for the vertical asymptotes. A vertical translation and a vertical dilation will not affect the position of vertical asymptotes. So for this part, we can ignore the 1 and the 3. You don't need to write this down, but you should be thinking the tangent of 2x is equal to the sine of 2x divided by the cosine of 2x. a vertical asymptote will occur where tangent 2x is undefined. That's going to be where the denominator, cosine of 2x, is equal to 0. So we need to solve this little equation. The cosine of 2x is equal to 0. First, we solve for 2x by asking ourselves the cosine of what is equal to 0. Cosine is the x value on the unit circle, and x values are equal to 0 here and here. This first solution at the top is pi over 2. I'm not making a list, so I'm not going to put comma 3 pi over 2. I need an expression for the infinitely many solutions to this equation. So instead, recognize that we can get from one solution to the next solution by adding pi. And in fact, every time we add pi, it takes us to the next solution. So we can write an expression for the infinitely many solutions by adding multiples of pi. In other words, by adding pi k, where k is any integer. We need to get x by itself by dividing every term by 2. So if we divide the first term by 2, we get x. Pi over 2 divided by 2 is pi over 4. And if we divide pi k by 2, we get pi over 2k. Let's look for which option has this as the asymptote expression. And there it is, x equals pi over 4 plus pi over 2k, where k is any integer. So the answer is B. Number 6. The graph of function h is given in the xy plane. Which of the following statements is correct? Scanning across the answer choices, first we have to decide if h is increasing or decreasing. Well, at a glance we can see that all of these little waves are increasing waves. From left to right, the graph is increasing. So that narrows it down to A and B, C and D are out. To choose between A and B, we have to decide whether h is increasing at an increasing rate or at a decreasing rate. Notice that when they say increasing rate, it means the rate of change is increasing. When they say decreasing rate, it means the rate of change is decreasing. Back in Unit 1, I had you memorize this chart showing the graphical relationship between f of x, the rate of change of f, and even the rate of change of the rate of change. If you never memorized this, or if you have forgotten it, pause the video and memorize the chart right now. To answer this question, we need this corner of the chart right here. The rate of change will be increasing wherever the original function is concave up, and the rate of change will be decreasing wherever the function is concave down. Options A and B both refer to the interval from pi over 4 to pi over 2. That's this portion of the graph, which is clearly concave down. And if the function is concave down, the rate of change is decreasing. This corresponds to answer choice B. Number 7. The graph of the function f is given in the xy plane if f of x is equal to a times the tangent of b times x minus pi over 4, where a and b are constants. Which of the following is true? Oops, it looks like the answers are on the next page, but they are asking us if a is greater than 0 or less than 0, and then if b is greater than 1 or between 0 and 1. So first of all, the a part is really easy. The parent function for tangent is an increasing function. The waves go up from left to right. Because these waves are decreasing from left to right, this is a reflection of the parent function. Therefore, the a value is definitely negative. So that narrows it down. the answer will not be A or B. So either C or D. Now let's talk about that B value. The period of a tangent function can be measured from asymptote to asymptote. From 0 to pi over 2 gives us a period of pi over 2. We can use this to find the B value. We have learned that for a tangent function, the B value is always pi divided by the period. So in this case, that's pi divided by pi over 2. When you divide by a fraction, you multiply by the reciprocal. So B will equal pi times 2 over pi. The pi's will cancel each other out because we have one high and one low, leaving B is equal to 2. Comparing that to the options that we have, since B is 2, that is greater than 1. So the answer is C. Number 8. The graph of the function h is given in the xy plane. If h of x is equal to the tangent of bx plus d, where b and d are constants, what are the values of b and d? We need to start with the period, which can be measured from asymptote to asymptote. From negative pi to positive pi is a horizontal distance of 2 pi. So the period is 2 pi. The period can also be measured from point of inflection to point of inflection. From 0 to 2 pi, again, is 2 pi. We know that the b value for a tangent function will be pi divided by the period. So that's pi over 2 pi. The pi's cancel out, leaving a b value of 1/2. So option A features a b value of 1/2, so does option B. But options C and D are out. The D value is the vertical translation. So look where the points of inflection are. This will tell you what the D value is, because when there is no vertical translation, the points of inflection are on the x-axis. The fact that these points of inflection are on the line y equals 1 means that we have a vertical translation by positive 1. So that tells us that the D value is 1. So the answer is B. Number 9. The graph of the function k is given in the xy plane. Which of the following could be the expression for k of x? I'm noticing that each of the options have a different b value. So let's calculate the b value based on the graph and see which one is a match. First, we will need the period. And we know that the period can be measured from asymptote to asymptote. From 1 to 3, that's a period of 2. Also, you can measure the period of a tangent function from point of inflection to point of inflection. So from 0 to 2, that also tells you that the period is 2. We have learned that the b value for a tangent function will be pi divided by the period. So the b value is pi over 2. That only matches with answer choice B. Find the exact values of the following expressions if possible. I am assuming that you have already memorized these 9 trig facts. If you have not memorized them, pause the video and study this chart right now. Number 10. In what quadrant is 2 pi over 3? Pi is right here, and we can think of pi as 3 pi over 3. Therefore, 2 pi over 3 is pi over 3 less than 3 pi over 3. It's right here in the second quadrant. The reference angle is the angle between the terminal side and the x-axis. So in this case, the reference angle is pi over 3. Since the tangent of pi over 3 is radical 3, the answer will either be radical 3 or negative radical 3, depending on the quadrant. In the second quadrant, the slope is negative. and the tangent always matches the slope of the terminal side. So the answer is negative radical 3. Number 11. In what quadrant is 7 pi over 4? Well, pi is right here, and we can think of that as 4 pi over 4. On the right-hand side, we can think of 2 pi as 8 pi over 4. Therefore, 7 pi over 4 will be pi over 4 less than 8 pi over 4, placing it right here in the fourth quadrant. The reference angle is pi over 4. So since the sine of pi over 4 is 1 over radical 2, the answer will either be 1 over radical 2 or negative 1 over radical 2. On the unit circle, sine is the y value, and in the fourth quadrant, y values are negative. We're below the x-axis. So the answer will be negative 1 over radical 2. 3 pi over 2 does not fall within a quadrant. The terminal side lands right here on the negative y-axis. When that happens, we use the coordinates of this point, which are 0, negative 1, because this is a unit circle. Every radius is 1. So on the unit circle, cosine is the x value. So in this case, cosine is 0. In what quadrant is 4 pi over 3? We can think of pi as 3 pi over 3. Therefore, 4 pi over 3 will be pi over 3 more than 3 pi over 3, placing it right here in the third quadrant. The reference angle is pi over 3. Since the cosine of pi over 3 is 1/2, the answer will either be positive 1/2 or negative 1/2. On the unit circle, cosine is the x value, and x values are negative in the third quadrant. We are to the left of the y-axis. So the answer is negative 1/2. In what quadrant is 7 pi over 6? We can think of pi as 6 pi over 6. Therefore, 7 pi over 6 will be pi over 6 more than 6 pi over 6. That puts it right here in the third quadrant. We can also tell that the reference angle is pi over 6. So, looking at the reference angle, since the tangent of pi over 6 is 1 over radical 3, the answer will either be 1 over radical 3 or negative 1 over radical 3. Remember that tangent is the slope of the terminal side, and in the third quadrant the slope is positive. So we will leave the answer as positive 1 over radical 3. Or you could put radical 3 over 3, which means the same thing. In what quadrant is 5 pi over 6? We can think of pi as 6 pi over 6. Therefore, 5 pi over 6 will be pi over 6 less than 6 pi over 6, placing it right here in the second quadrant. Therefore, we can tell that the reference angle is pi over 6. The sine of pi over 6 is 1/2, so the answer will either be positive 1/2 or negative 1/2. On the unit circle, sine is the y value. In the second quadrant, y values are positive. We are above the x-axis. So we will leave the answer as positive 1/2. In what quadrant is 3 pi over 4? We can think of pi as 4 pi over 4. Therefore, 3 pi over 4 will be pi over 4 less than 4 pi over 4. This falls in the second quadrant, and that tells us that the reference angle is pi over 4. The tangent of pi over 4 is 1. So that means the answer will either be positive 1 or negative 1. In the second quadrant, the slope of the terminal side is negative. See how it goes downhill? That tells us that the tangent will be negative 1, because tangent is the slope of the terminal side, rise over run. We have memorized that the cosine of pi over 4 is 1 over radical 2, or you could write radical 2 over 2. In what quadrant is 5 pi over 3? we can think of pi as 3 pi over 3, and we can think of 2 pi as 6 pi over 3. Therefore, 5 pi over 3 will be pi over 3 less than 6 pi over 3, placing it right here in the fourth quadrant. This also tells us that the reference angle is pi over 3. Since the sign of pi over 3 is radical 3 over 2, the answer will either be radical 3 over 2 or negative radical 3 over 2. On the unit circle, sine is the y value. Since y values are negative in the fourth quadrant, the answer will be negative radical 3 over 2. In what quadrant is 11 pi over 6? We can think of pi as 6 pi over 6. We can think of 2 pi as 12 pi over 6. Therefore, 11 pi over 6 will be pi over 6 less than 12 pi over 6, placing it right here in the fourth quadrant. This also tells us that the reference angle is pi over 6. Since the cosine of pi over 6 is radical 3 over 2, the answer will either be radical 3 over 2 or negative radical 3 over 2. On the unit circle, cosine is the x value, and x values are positive in the fourth quadrant because we are to the right of the y-axis. So we will leave the answer as positive radical 3 over 2. Pi over 2 does not land in a quadrant. It lands right on the positive y-axis. So we don't need these values. We can just recognize the slope of a vertical line is undefined. And you know that tangent is always the slope of the terminal side. So tangent will be undefined at pi over 2. 3 pi over 2 does not land in a quadrant. It lands on the negative y-axis. When that happens, we can use this intersection point that's on the unit circle, which is the point 0, negative 1. Because on the unit circle, sine is the y value, and in this case, the y value is negative 1. So that's the answer. Tangent is the slope of the terminal side, and pi radians falls right here at the semicircle. That means the terminal side is horizontal. So automatically we can see that the slope is 0, so the tangent is 0. 2 pi is all the way around and back to where we started from. This falls not in a quadrant, but on the positive x-axis. When you have a sine or cosine that falls right on the axis, you use the intersection point on the unit circle. In this case, that intersection point is 1, 0. On the unit circle, cosine is the x value, and in this case, the x value is 1. So the cosine of 2 pi is 1. In what quadrant is 5 pi over 4? We can think of pi as 4 pi over 4. Therefore, 5 pi over 4 will be pi over 4 more, placing it into the third quadrant. This tells us that the reference angle is pi over 4. Since the sine of pi over 4 is 1 over radical 2, the answer will either be 1 over radical 2 or negative 1 over radical 2. On the unit circle, sine is the y value, and y values are negative in the fourth quadrant. So the answer will be negative 1 over radical 2. Or you could say negative radical 2 over 2. Hey guys, don't forget to like and subscribe. But also, if you found this video helpful, there's a lot more where that came from. You can click the upper link, which will take you to the whole unit playlist, or you can click the lower link, which will take you to the next video in the playlist. See you there.